Hey guys, so as promised, I'm back to do the configuration demonstration for the actual DMVPN tunnels. And what we're going to focus on is going to be router 1, 5, and 3, as I stated before there. So let's go ahead and jump into the command line. Well, before we jump into the command line, what I did do beforehand was I did configure EIGRP before. Got the network statements all laid out there. So the only thing that's missing right now is the actual tunnel interfaces, because I want to spend more time looking at the DMVPN operation rather than typing in the command. So I pre-typed out the commands in the notepad here, and I'm just going to show you guys line by line what each command does, and then we'll paste it, and then we'll start doing some verification. Just so, like I said, we can save on some time here. So one of the first things we want to do is we want to make sure that we got connectivity on the NBMA network. We kind of did that in the other video, but just to be sure, we're going to run this TCL script. Let's see, TCL shell, and then TCL quit. Alright, so we're just going to run this little script here on each of the routers, on the hub and the spokes. So router 1, we'll run this one first. We can see we got pings going out to all the interfaces for all the NBMA. Same thing with router 3. We see we got connectivity. And then same thing with router 5. You can see we got connectivity. So we now that was just us defining out what our underlying network is. That's working good. So the NBMA access. And if you go back to the diagram, we just pinged the 10.100 networks that we're using to actually peer with the ISP. So we got connectivity to the ISP. Perfection, right? Now, let's look at the configuration that we're going to need to actually get the tunnels done. Now, these are the different, these are the tunnel interfaces. This is going to be my hub and my 2 spokes. So we'll focus on the hub first. And in this configuration, we're going to focus on doing phase 1. Before we go into phase 2 or phase 3. So tunnel 100 right now. Make sure I put the right IP address, of course, and then the right sub interface. And 201. Okay, so as you can see, obviously that's the IP address for the tunnel. In the Cisco documentation for DMVPN that I showed you guys earlier, they have a recommended configuration that you can follow, which I usually use as a template as I do my configurations. So that's something to keep in mind. It's on this page here, and if you go to, they have different ones. So let's see, configuring the hub for DMVPN, as you can see, that's their template, and then they have one for configuring the spoke. So I would go by that if you're not familiar with the commands off the top of your head. And for the CCIE lab, it can be to your benefit to know this, but you know, to all the different nuances, especially all the different things that we're gonna have to end up configuring, just know where the documentation is if you need to do a quick reference if you don't remember a specific parameter. But going into it, this sets the MTU to 1400 so that fragmentation doesn't actually happen over the tunnel. Then you got your NHRP authentication string, which is going to be MPLS in this case. This NHRP map multicast dynamic, that is the equivalent of your frame relay map command, and you have the broadcast statement, and you do the pseudo broadcast. That's essentially what this does. And if you're not familiar, with pseudo broadcast, it's just when your router thinks when you want to send a broadcast, the router actually reconfigures the packet, so to say, and instead of sending to a broadcast, it's actually sent it as a unicast broadcast to specific neighbors. So that's what this command is doing. The network ID is the logical identifier for the DMVPN network. So you could have this just pretty much tells the spokes, hey, if you have this and this, you are on the right network, right? The TCP adjust maximum segment size, we already know what that is for TCP windowing. And then tunnel source, which is my Ethernet interface going out to the MPLS cloud. And then you got tunnel mode GRE multipoint, which configures this tunnel to be a multipoint interface. So let's drop that down and make sure that it gets taken into router 1. So we'll do a quit config T. those commands. Beautiful. We should see a tunnel come up. Show, and we just did show IP interface brief, and okay, so we have our tunnel here. So tunnel's up and running, perfect. Now let's go and do our spokes. Same deal with router 3. Now, like I said, since we're going to do a phase 1 implementation, we're not going to see this command there, but I'll show you why. So tunnel 3, router 3 for tunnel 100, we got the IP address. That's for ICMP redirects. We don't need to worry about that. MTU 1400, same thing for the segment for fragmentation purposes. You got your MPLS authentication string. Now what's different here is that you have your NHRP map commands. Now what this does is it's saying map this tunnel IP, which is the hub's tunnel IP, to its NBMA access, right? And it says map any multicast traffic to this NBMA access, and it's the same deal. Now, whenever you send multicast or any kind of whenever you send any kind of traffic, it essentially knows to get to this router here, and then you would specify your next hop server with this command. So that's how the router knows that router 1 is actually the DMVPN hub for the network, and then your tunnel source, which is your source of the tunnel. So go ahead and drop this command here, drop these commands here for router 3. Oops. Make sure that I did grab router 3. I know earlier I had that kind of mixed up. So we got router 3. Perfection. And we drop that tunnel. Beautiful. Now, what you're going to see is the tunnel stay down for router 3. And you'll notice that the reason why that is because I didn't configure this one to be a GRE multipoint, and that is because of the fact that we're gonna make this on phase 1 point-to-point tunnel. So what we're gonna have to do for router 3's tunnel interface, config T interface tunnel 100, right? So you would just do tunnel destination. Right? And the tunnel destination you're going to specify here is not going to be the tunnel IP of router 1, which would be the 55.0.100.1. It's actually going to be the NBMA address, right? Because if you're configuring a standard GRE tunnel, if you were doing 2 point-to-point tunnels, what would be your tunnel destinations? It would be the actual transport IP that the GRE is going to, the GRE shim is going to get inserted in front of, right? So this essentially is your transport network, and that's what you want to specify in that command. So you can do it by the I do it by the IP address. So you do 10.100.0. Now 1 is the ISP, 2 is my next hop server, and as you can see, my tunnel should come up after we do that command. Yep, and you see it came up. And remember how I said that I actually had EIGRP pre-configured? You can see that EIGRP actually came up over that tunnel. So we got neighborage agency with router 1 already. Now let's move to router 5. Same deal. Now everything is pretty much the same until we get to, and actually this command is not needed. This is actually only needed on the hub. Didn't mean to do that. So delete that. That command is actually only needed on the hub. So here. Now, you'll notice there's a couple of command differences here. So what you're seeing here is exactly what I'm doing here. It's just they made it a little bit easier, and I don't know if it's depending on what iOS version. Mine has this ability, and I didn't see a functional difference when I configured it using this way. I didn't see anything in the documentation saying it was going to do anything differently, but just if you want to cut down on actual commands that goes into the router, this is an optional way to configure the next hop server. Same deal, specify the tunnel IP where the next hop server is going to be communicating on. The NBMA, which is going to be the underlying IP address that we're going to use to reach the next hop server. And then multicast, saying that, hey, map multicast traffic to this next hop server via that NBMA address, right? We're going to take this command out as well because we want to keep this as a point-to-point tunnel as well. So let's get to router 5. This is the fun stuff, man. I love this stuff. Alright, so configure T. We drop that. And we should see the tunnel come down. Oh no, oh no. So, let's get into the tunnel. Now, same deal. Interface tunnel 100. What we're going to need to do, since we're configuring this as a point-to-point tunnel, we're going to have to specify the tunnel destination. And at that point, the tunnel destination should be 10.100.0.2. Right? And then we should see the tunnel come up, and we should see some adjacencies happening. Come on, come on. Tunnel up. Come on, EIGRP. Then we got EIGRP. Beautiful. So, let's do some verification here. So, one of the things that we can do on the hub, just to make sure registration occurred correctly, we can do a show DMVPN. And show DMVPN is a combination of multiple outputs, I believe. But this essentially, this is what the your NHRP table is going to look like. Right. So here is your MBMA address for your peers. This is your the actual tunnel IP. You can see that's in a state of up, and then you can see that the attribute is marked as D, which stands for dynamic. So you'll notice that the hub will always learn its spokes dynamically, because that's the registration process. They're going to talk to the next top server. Next top server is going to say, hey, I'm going to put you in my table now. That's pretty much how that goes. And you'll see this here that we're on the hub based off of the type hub. From the configuration, the router knows that itself is a hub. And then another command you can do is show IP NHRP, and that'll just show you the actual NHRP entries that the router created, right? Registered using unique next time. Beautiful. So we can see that happen. Now, looking at the spokes, look at that same output. Show DMVPN. Now, same thing here. You see the MBMA address for router 1, and then you see the tunnel IP for router 1. But you see the attributes a little different because it's static, and that's because we actually have those map commands there. So that will show static in our configuration. And if you look, you see that we are type spoke, so it knows that this is a spoke. And same deal here. Show DMVPN. Same thing here. It'll show us as the spoke, statically learned. Blah, 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 blah. Now, let's make sure we got some routes here, right? So, I already kind of know what the expected result is going to be. I just want to show you guys kind of the process that I follow when troubleshooting. So, 5.100.1, well, we want to do the loopback addresses. So, 5.100.5, alright, 155.3.3, and then 155.0.4, 3. What the heck am I doing? I got 5, 3, and 1. 1.1. Beautiful. So let's go ahead and run this command here and see what our results are. So we'll start with router 1. Well, we'll start with router 3. So we failed to router 5, but we made it to router ourselves, of course, then we made it to router 1. Okay, alright. Same thing, let's go to router 3 and do the same thing. I'm sorry, router 5 and do the same thing. Now, you see we pinged ourselves. We seem to fail on 3. And we passed to get to 1. So something's going on to where we're not routing to router 3. Router 5 is not routing to router 3, and router 3 is not routing to router 5. Wonder what that is. We all should already know this. This is going to be split horizon, right? So what you're going to have to do at this point is back on the hub, and we can verify that, right? If we do a TCL quit, and we do a show IP route, and we're going to do it on that loopback address for router 5, so 155.0.5.5. You notice subnet's not in table, so that is kind of sucks, right? Kind of a drawback on that. So what we want to do now is let's go ahead and enable split horizon to see if we can get that routing update, because router 1, let's run that same command on router 1 and see if router 1 can reach all those networks. You know, I'm assuming that it's split horizon. I could be wrong. Let's just make sure. So we can ping router 5, 3, and it's router 1 itself. So to me, now this is sounding exactly like a possible split horizon issue, right? So we want to do TCL quit. We want to do config T interface tunnel 100, and so we want to do that. No, that's magical command. No split horizon. No IP split horizon. EIGRP, and then the process number, and that should disable split horizon. Now, when we go back to do a show IP route, you notice that we got the tunnel reset, the neighbor resets, and now we got a route to router 5. So I should be able to ping router 5's loopback, sourcing it from router 3. Ooh, wrong IP address. I didn't want to do that. Source loopback 0. Alright. You can see connectivity is happening. Woo woo. Right? So we did those pings. So now what we want to do is, remember how I said with phase 1, the problem with phase 1 is that the traffic will always have to traverse the hub in order to get to the other spoke. So we can verify that. We can do a show DMVPN. You can see we only still know the static entry for the next hop server. And if you do a trace route to router 5's loopback now from router 3, you see that it makes that hop through the hub first, then it gets to the actual router. It never does a spoke-to-spoke communication. Now, one of the cool things that you can do in this option, so right now I have it to where the specific route is actually showing up in the routing table. What I can do is I can set up a default route that the hub is actually sending out, so the specific routes aren't actually needed, and maybe I don't want to enable split horizon, right? Let's go ahead and do that. So we'll go to router 1 and we'll do IP split horizon EIGRP 100. And that re-enables split horizon for it. And if I do a show IP route, alright, so show IP route 155.0.5.5. You notice the subnet's not in the table. But what we can do is this. IP summary address EIGRP 100 0.0.0.0. I can do a /24. Wow, I can't. 0.0.0.0. Beautiful. Alright, so we'll go ahead and add that summary address. We should get the neighbors resyncing. Come on. I wonder if it's going to resync. Okay, there it goes. Alright, so there's the resync. We do a show IP route. You notice that it's not in the routing table. We'll show IP route. Right? It's not in the routing table. But, based off of the default route, ping 155.0.5.5, going into the both routers, we should be able to reach router 3. We should be able to reach router 5 through router 3, and we could do that trace route just to make sure that we still have connectivity. Dot 100 dot 5.5. You can see it's still taking that next hop to go through the hub. So either way, both of those commands can accomplish the same task. Best practice design with DMVPN, even though it's a very phased out approach to DMVPN, typically you'll have that default route coming from the hub, and then just to keep the routing table small, you don't actually need to enable split horizon. As long as the routes make it to the hub, that's all that matters, because you have the default route going to the spokes, get to the hub, and then the hub will take you to where it needs to go. So, just keep that in mind, but just know that if they say, make sure, if you get a question or something and it says, make sure router 3 can ping router 5, but do not use any summary addresses on router 1. then you know that's possibly going to be a split horizon issue if it's a routing going through the IGRP or something like that, and vice versa. Or if they say, hey, make sure router 5 can ping router 3, but do not disable split horizon. And that they can say do not enable split horizon and do not use a static route. So that you get into those type of scenarios, and then you got to start thinking outside the box on when to implement. So this video was a little longer than I anticipated, so it looks like I'm going to do a couple videos per phase. So that was my phase 1 video. In the next one, we'll go over on configuring phase 2.